Today we're going to be talking about the three types of radioactivity. Radioactivity is the process by which an unstable nucleus emits one or more particles or energy in the form of electromagnetic radiation. Basically, what happens is the nucleus becomes unstable because it becomes too large, or there's just too many neutrons for the number of protons in the nucleus. And the nuclear radiation are the particles that are emitted during radioactive decay. The types of radiation are alpha, beta, and gamma. And here, this picture is showing the penetrating power of alpha, beta, and gamma, and then a couple other types of radiation. So you can see here, alpha can't even penetrate paper, so it's a poor penetrator. Beta can penetrate paper and a little bit into the skin. And then gamma rays, they can penetrate paper, skin, wood, all the way up into cement, or it can also be stopped by dense materials such as lead. And then a neutron emission can penetrate even further. And we're going to talk about why in the future in the future of this presentation. Alpha decay was discovered by Rutherford, and it's 2 protons and 2 neutrons, which makes it a helium nucleus. It's right here in the equation here. 4 is the mass number and 2 is the atomic number, so it's the nucleus of a helium atom. It is positively charged because it doesn't have any electrons. It has a +2 charge. It's the most massive type of radiation, having a mass of 4. And it can't travel through materials because it's massive and it has a charge. It's going to interact with materials and stop very quickly. Here in this equation, that might look pretty confusing to you guys, but don't worry, we will figure that out together. But the A stands for the mass number, and Z is the atomic number. And these X's and Y's, the X stands for the element symbol of what we like to call the parent element, and Y is the symbol for the daughter element. So what happens in the equation is that the parent element's mass number will go down by 4, and its atomic number will go down by 2. We also like to say, if you look on the periodic table, you go back 2 places when an atom is going through alpha decay. Beta decay is a fast-moving electron, and it has a negative charge because it's an electron, and it can penetrate a little bit further because it's less massive, but it also has a charge, so it will interact with the other atoms, and it'll eventually be stopped by less dense materials such as aluminum. It can ionize other atoms because they are negatively charged, and they lose energy very quickly. Here's the equation for an alpha decay. Since an electron has no mass compared to protons and neutrons, we can see that the atomic number is going to stay the same. Or not the atomic number, rather, sorry, the mass number stays the same. The atomic number, on the other hand, increases by 1. And that's because in a beta decay, a neutron is losing an electron and therefore turning into a proton. So since the neutron is turning into a proton, its atomic number goes up by 1. Gamma rays are the highest form of energetic radiation. They have no mass and no charge, so that allows gamma rays to penetrate very deeply, and they can cause damage to matter or cause tissue damage. These are the ones that are going to be dangerous to our health. They also don't have an equation because they don't cause a transmutation. What that simply means is it doesn't cause an element to turn from one form to another. Here's a little picture. We have plutonium undergoing gamma decay, and it's still plutonium. So it didn't change into another element. And then the fourth one we don't really talk about a whole lot, just basically what it is. A neutron emission is a high-speed neutron that's given off from a nucleus. This typically happens in our outer atmosphere when it's being bombarded by cosmic rays. And this also ends up forming carbon-14, which is important in radioactive dating and geology. That's it for today.